Hello, we are the SOU Winter Capstone team who worked on the U.S. Fish and Wildlife Service Forensics Database project. My name is Mariah Reibel, and my teammates are Brandon Codd and Ty DeMarco. So, in this presentation, we are going to discuss our motivation for the project. We will talk a little bit about what the Fish and Wildlife Service Forensics Lab does. We'll discuss the major requirements and features of our project, tools and technologies we use to accomplish it. We'll give you a version 1 demo, talk a little bit about our testing and division of labor, and then our deferred features that we will be working on during spring term. The U.S. Fish and Wildlife Service Forensics Lab is just like your regular forensics lab, except their cases and data are based upon fish and wildlife. They have the same status as the FBI, and their detectives there are considered to be on the same, level that an FBI detective would be. They analyze forensics data related to things like trees, animals, and birds. For example, if an endangered species is being illegally sold or killed, the FWS Forensics Lab is where the evidence is handled. They have thousands upon thousands of specimens that they use for reference. So essentially, when they receive evidence for a case, they will take that evidence and they will compare it to the reference data that they have at the lab to determine what the evidence is. So if it's like a part of an animal, they'll compare it to parts that they already have to determine which kind of animal that is. So these specimens, they have thousands upon thousands of specimens, and they need some form of interactive application where they can see where this data is located, what it is, and the different aspects about it. So that is sort of the background on the Fish and Wildlife Service and this project and why it's needed. So they already have an existing application. This application was designed by the 2020 SOU Capstone team, so the year before us. They created a back-end database and a front-end web application for the forensics lab to use. So we will be adding new data sets to this web app. We're going to be adding the mammalogy, which is mammals, and genetics data sets. Currently, they keep all of their data in CSV files. So here is an example of what their data for their mammalogy data set looks like right now. This is exactly how they would look at it at their lab. You see, we literally just have a spreadsheet. This is a spreadsheet. So if you wanted to find something specific, you're just, Control F. Cheetah. So, as you can see, this is not the most effective way of keeping data, especially if you're doing something important like, a forensics case. And so this has, 4,000 lines. So it's a lot of data, and they need a good place to keep this data and a good way to access it. So the application that exists right now that we're going to be adding onto is a web platform that allows the user to search, add, edit, view, and delete. There are 3 current existing data sets already within the database. They are herpetology, which are reptiles, xylarium, which is wood, and criminalistics. We did have some challenges going into this project because we started with a project that we did not design. So we had some issues in the beginning of implementing the existing code into our own environment. There wasn't a lot of code documentation that we were given, so we really had to figure out everything ourselves. And we had several instances where we were given multiple different versions of the code, and we had to figure out which one was the most up-to-date. But in the end, we figured it out, and we have successfully added a new data set into this web application. So the major features that we implemented this term was for the mammalogy data set. So we implemented the search function, so a user can type into the search bar and get results back. They can view data, edit data, delete data, and add data. And we are in the process of implementing what is called a bulk add feature, where a user can take a CSV file and fill it out with multiple different lines and add all of those lines into the database at once. This is an existing feature. We will just be implementing the mammalogy dataset into it. And then we're also going to be working on improving written documentation. So with that, I will be handing it off to Brandon Codd to talk about our tools and technologies and give you a version 1 demo.
Following our predecessors, we use much of the same tools and technology. One difference is that we decided to use Amazon AWS as the hosting service for our database. This allows for the data to be in the cloud and accessible from anywhere. Our client extensively uses Microsoft products. As such, we use SQL Server Management Studio to manage the various database scripts and queries to best in line with our client needs. For the front end of the web app, the previous team had used React and Node.js. This allowed the previous team members to create a clean and minimal user interface, and as such, we will be continuing to use these tools. Our development environment of choice was Visual Studio Code. VS Code supports and integrates many packages such as those described above. It also has embedded Git, which helps in version control during development. I will now move on to a demonstration showcasing the Momology dataset. Now let's run through a demo of the application. As you can see here, we have the web application running. Our goal was to add the Momology dataset to this web application. First, let's make sure that data is actually being populated. We click on Momology and hit search. As you can see, various specimens are popping up. Now let's move on to adding a new specimen to this dataset. By clicking Add New in the top right, you will be presented with a pop-up window that has various fields for you to enter into. For this test case, let's name the common name test mam. And for the catalog num, we'll name it mam 999. We hit save, and we will be presented with another pop-up window asking us to confirm. We could either resume editing or confirm this entry. We hit confirm, and at the top you will see a green check mark indicating success. We can now close this window, and if we hit search again, we can go to the bottom of our results and see that testmam has been successfully inserted into the web application. Sometimes adding in an entity one at a time is just too time consuming. As such, there is a bulk add feature. Click it in the top right, and depending on which database you are, you will be presented with a pop-up showcasing a template for that dataset. Since this is the Momology table, you're presented with a Momology template, which if you open, will give you a CSV file that allows you to enter in bulk data. Once you've added your bulk data, you can choose that file, and once you open it, it will give you another pop-up showcasing the data that you're about to add. As you can see, we're about to add 2 new entities into the database. We hit save, and another green check mark will pop up indicating success. Once we close this and search our results again, we can scroll down to the bottom and see that we've successfully added this data to our database. Now let's attempt to search for the value that we added earlier. As you can see, there's various fields you can select to help with your search. Let's search by common name and look for that value that we entered earlier. We select testnum and hit search. As you can see, testnum pops up here. If we click on testnum, you'll be given a view and edit specimens detail page. On this page, you can update your values or edit them to include new ones. Let's now edit this from testmam to testmam1. Once you hit save, you'll be given another pop-up page to confirm your changes to make sure they're in line with the rest of the data. You can either continue editing or confirm the save. Once we confirm the save, another green check mark will pop up showcasing success. Let's close this, and now we see that our common name has been edited from testmam to testmam1. Now let's showcase the delete feature. Click again on the value here, and in the bottom left you will see delete specimen. A pop-up will confirm whether or not you want to delete the specimen, and we hit delete. As you can see, the entity has been removed, and if we get rid of the search term and search again, we will see that the entity is no longer in the web application or the database. And now I will hand you off to Taida for the rest of the presentation.
Hi, I'm Taida, and I'll begin by talking about our testing. On screen is part of our test plan for the major features we implemented during winter term. As you can see, the test plan followed the demo that Brandon just gave quite closely and ensured that all our major features such as search, view, edit, delete, add, and bulk add were all working as intended. During the testing, we did come across some bugs here and there, but made sure to document them all for future debugging. Next, I'll be talking about division of labor. Brandon and I worked more closely as we worked together on the front-end code that involved Node.js and React. Basically, we were working on the website that the user can see. We were more focused on implementing and testing our major features, as well as debugging as much as possible. Mariah focused more on the back end of things. She created the SQL Server database through AWS and continues to work on it by implementing scripts from the original project, as well as creating all the new database tables, views, procedures, and triggers that we may need for the front end. She has also been our primary lead for contact and communicating with our client as well as the previous project developers. When we get together and work as a group, we usually focused on documentation as well as planning current and future tasks through the GitHub. We plan to keep similar roles for the next term. Next is our deferred features for spring term. We plan to implement one more dataset called genetics, which will have similar features to Momology. As requested by the client, we also plan to add global searching, which will allow a user to search across all the datasets at once, rather than having to choose only one. We also plan to do more bug fixes, as well as clean up the given fish and wildlife data. Two other features we will explore and possibly implement is a map report and user permissions. A map report meaning that an actual map will display the origin location of the search specimens. And user permissions would involve things such as an admin or user roles. For example, an admin would be given the permissions to edit and delete, while a standard user would only be able to search. Overall, during winter term, we were able to expand the client's database by adding the Momology dataset. We also revised the client's web application, allowing for more search capabilities and functionality with the Momology dataset. These additions help improve efficiency at the Fish and Wildlife Forensics Lab by providing an intuitive search for specimens. These searches help determine the lab location of the specimens so that they can be found faster, and overall speeds up the retrieval of any specimen they may need on the job. We also made additional documentation that is meant to explain the big picture on all scripts and code, which will hopefully help future development teams pick up the project faster. We have a lot planned for spring term and are excited to continue working with our client on this project. Thank you.